Hi students, welcome to lecture 2 of week 2 of Smart City course. So in previous lecture we have seen about how we can use the information and data and information technology to transform the government operations. In present lecture we will see the role of in ICT architecture and the IoT stacks to provide that governance operation to to support those government operations. So in today's lecture actually we are going to talk about whatever the information sensors or information infrastructure is going to be used in order to provide the e-governance. Those infrastructure we will talk about. So as a human being see any problem, so in order to solve the problem, first we need to see that problem through our eyes, and then those messages will convey to our brain. Then brain will assess those whatever the information, whatever the messages are there, and then it takes some decision, and based on that decision our body reacts. In the similar way, if we want to provide the smart solutions to any city, we want to transform it in the smart city, we would like to provide a ICT stack. From the engineer's point of view, we will see city in the 4-layer stack, in which the layer 1 will be our sensing layer, or the you can see for an example like our eyes. So there may be some cameras associated, or maybe some RFID sensors, maybe some smart meters, or anything it could be. Then the next layer will be the network layer. That network layer may be provided through different technologies. It can be 4G, it can be using fiber, or it can be using some other technology. So in this network, whatever the sensing layer is sensing layer collects the information, those information will be conveyed through this network layer, and ultimately those informations will be brought to the to any platform, or you can say it as a processing layer. So this will be for an example, it could be a cloud or it could be a analytics, and based on whatever the processing happens, a decision would be made at this layer, and whatever the output will be there, that will be displayed in the application layer, which is going to be the 4th layer in our stack. And that layer is actually, you can have an example like dashboards or some apps in which you will see the information. You can understand all these layers like the sensing layer, like eye and ears. You may have some camera, you may have some system, some sensors, maybe some lights, traffic lights in the traffic system. Then you have the network layer, or you can see the nervous system, maybe some fibers, maybe Wi-Fi, maybe some other type of technology. Then you have some platforms, maybe some cloud or some other computational platform, where all these information will be collected and will be processed. Based on this processing, there will be some result, and those results will be displayed in maybe some app or in some dashboard form, and will be available to you. So let's try to understand each layer in detail. So as I already mentioned, the first layer is the sensing layer, which will actually see what information or it will get the initial information. So for an example, it could be eyes or ears of your body. So similar, you may have examples what you can provide in a smart city, like some environmental sensors are there who can sense the level of pollution, or maybe the concentration of PM 2.5, maybe the concentration of CO2, or temperature, moisture, humidity, etc. There could be some visual sensors. It could be in the form of some CCTV cameras, maybe automatic number plate readers kind of cameras, or maybe others. Some utility sensors, some examples are smart water meters, which can usually collect what amount of water load is there at a particular time. Then you have smart energy meters, which can collect in real time what is the electrical load. Then you may have some positional sensors like GPS on buses, trucks, etc. The key constraint while you are using these kind of sensors is the power, because whatever the sensor you use, that will consume some amount of power. Like if it is a CCTV cameras, or if it is a Other sensor, environmental sensors, like to sense the AQI or PM 2.5 or CO2, they will consume some amount of powers. Now, because power is something which we cannot supply to every sensors, because there are certain sensors like smart water meters or maybe some other sensors which are embedded into the layers. Like for an example, you can see if we want to give a solution for smart pavement, then we need to embed it some kind of sensors in the pavement itself. Now, if sensors are embedded in the pavement, you cannot change the batteries, you cannot provide the powers in the real time basis, and you cannot also change the batteries at frequent durations. So we require some solution which may use batteries in a very minimal amount, so that our battery may last for years. Then we have second layer, the network layer, where all these information which is collected from the sensing layer or layer 1 will be conveyed through this layer. So network may be a different type of network system you may use. You can say this is a kind of pipe through which the information will flow. For example, you may have the optic fiber types of technology in this. You may have 5G or 4G, you may have Wi-Fi, or you may have a low range wide area network type of system or LoRaWAN. So based on their speed, range, their use cases could be different. So like fiber optics, the speed is very high, but the range is fixed. You can only extend the services only where you are able to provide the fiber. So range is fixed, and use cases are you can use them in the CCTV systems. Then we have technologies like 5G or 4G. Again, the speed is high, but the range is medium. Now range is higher than the fiber optic system, but here the range is little bit higher, but it is again medium, it is not very large. So you can use this type of system maybe in drones. Then we have Wi-Fi. Now Wi-Fi speed is very high, but again the range is short, and you can use this type of sensors, this type of technology in the public hotspot. Then we have LoRaWAN kind of technology, or you can say low range wide area network type of technology, where speed is very low but the range is very long, around 10 kilometer of range we have. And you can use this where the systems requirement is to consume very less amount of battery. So like smart water meters or maybe the road sensors. So this will require very less, the requirement is to use very less amount of energy. So that is why these kind of systems can be used, because their objective is not to get the data very frequently. Even if we get a one data point in an hour, it is okay for us. So these all technologies, depending upon what use case is there, you can select what technology you want. So as I already mentions, the use of technology or use cases will depend upon the different use cases. The focus will be to use a low power wide area network. So in these type of technology, actually the penetration is very high. The waves can reach even the underground, and this is actually a kind of advantages, because some of the sensors like smart water meters, maybe the pavement sensors, maybe sensors associated to building, they may be embedded into the structure, and there we want to penetrate the structure itself. Again, the power consumption. Now the devices sleep 99% of the time, so that is why the constant the power consumption. So these devices sleeps around 99% of the time. So their battery will last for years, 10 years or more than that. Also the cost of spectrum as compared to 4G, 5G, the spectrum cost is very low. So although the latency is high, but it is okay, because we do not need to send the data in a very high frequency rate. Even the data in 1 hour, 2 hour, or one data point in a day could be sufficient. So that is why these kind of technologies are still very usable in the case of maybe smart water meters or some sensors which are embedded in the structure itself. The third layer, as I already mentioned, is the platform layer. So this is the layer where you will collect all the data coming from the network layer. So whatever the data is stored will be processed in this layer. Here we could have a data lake or repository where we have all the raw data in the form of videos, text, or maybe a user log. Then we have a middleware. The middleware is where whatever the data you have collected, that data will be converted into the common format, or you can say that can be converted into the common form, so that all the information can be exchanged coming from the different sensors. Then we can have an API gateway where we can expose these data to the different apps where these data can be available, or maybe the decision process from this data may be available to display. Okay, so there could be two types of computing technologies which can be used in the smart city context. One is a cloud-based technology, or you can say cloud computing, and other is the edge-based computing, or edge computing you can say. What happens in the cloud computing? The system will send all the data to the central server where process will be done. The advantage of this technology is it's have a infinite power because it is a cloud-based solution. So in cloud we have the numbers of computing hardware installed, so we have the infinite amount of power available. But the cons is latency and bandwidth cost. So cost will be more, as well as there will be some difference while you will send the data and receive a conclusion. In edge computing, what happens? It process all the data at the source. That means if you are collecting the data through the video camera, that data will be processed within the camera itself. It only sends alerts to the system. So processing happens at the same place, but the alert will be sent to the server. The pros of this system is it is very fast as compared to the cloud computing because all the process is happening at the same source. The privacy is also very prominent as compared to the cloud computing because actual data is not communicated through the server. So that is why there will be utmost amount of privacy. Like video will be inside the camera only, it will not leave the camera. So there is always a higher amount of privacy in the edge computing. For an example, let's try to understand a scenario in the traffic. Let's suppose we have an ambulance which is approaching a red light. Now in first approach, which is a cloud computing based approach, where camera will send a video to the server and server will analyze this scenario, like some ambulance is coming and we need to give a green signal, and based on this analysis the signal will become green. So it will take some 2 to 3 seconds of time because it requires the data to be sent to the server and then it will get processed and the server will send its response to the traffic light. While in the edge computing approach, you have camera which detects the siren. Now based on the voice detection, that siren will be detected by the camera, or maybe based on the video processing, it may assess that there is some ambulance, and locally this information will be processed and it will directly gives information to the traffic light and the traffic light will get green. So there is almost some milliseconds time will be required to convey this information. Then we have our final layer, which is layer 4, the application layer. In the application layer, whatever the processing happened or whatever the data collected in the previous layer, that will be displayed. So it is a kind of user interface, you can say. It may be a dashboard for a city administration, like some in the form of some graphs or some maps. Then you have you can have a citizen apps where you have all the reporting issues like for pothole fixes, etc. Then you may have some open data portals where you can provide all this information, which can be accessed by the third party, maybe by some some startups, or maybe some companies which provide some smart solutions. They can access this information, and based on these information they can provide you the decisions, etc. For an example, like your whatever the cab booking platform you have, while it's a Ola or Uber, they take information from the Google services, Google Map services, and based on that information, actually they provides how much time it will require to reach a cab to you, or how much time it will take you to travel a certain distance. Then the next information or the next sensor what you can have in the smart city context is the GIS, or the geographic information system. This geographic information system is actually a canvas of your smart city, which will have the information where all the sensors are fixed. So you will actually have the sensors coordinate in the form of XYZ, and you will have all the base maps, like whatever the roads are there, whatever the buildings are there, these all information will be embedded in your GIS maps. And it also have the different layers, like maybe information related to whatever the water pipes are there, whatever the electrical lines are there, whatever the fiber cables, or some other type of services. So this GIS map will have all the information. So based on the need, you can have these information right at your hand. For an example, let's suppose you want to do some digging operation for a road. So you can check the GIS and ensure that during this digging operation you are not cutting any fiber cable, you are not disturbing water supply lines, etc. Then the next thing is the interoperability of the informations. Now the problem associated here is our different department does not communicate with each other. Like the traffic department uses system A, the police department uses system B, and these system A and system B are not compatible with each other to share the information. Now here solution could be, we can provide a common API where we have all the informations of system A and all the informations of system B available, so that wherever it is required, the information can be shared. For an example, here you can see we have two departments. The interconnection between these departments is not possible, but adopting this API hub, we can have all these information shared, and based on this shared information, a standardized way for the software to ask question to the other software is possible. For an example, the Uber may ask question from the Google API that how much distance is there from a point A to point B. Also, it can have the information that how much time will require in order to reach from point A to point B. Then there are different protocols in order to communicate between these different elements of the smart cities. Like we have MQTT, which is lightweight messaging for IoT. It can be used from machine to machine communications. Then we have other form of communication protocols, which are HTTP and REST and RTSP, which can be used to communicate between the apps. RTSP can be used to communicate between the CCTV camera, or may be used to stream the video. Okay, next issue is related with the security in the information technology systems. Like whatever the systems are there, they are joined with each other, so there is always possibility of some cyber attacks or some hacking. So in order to secure this system, we need to use sufficient or secure mechanism, so that whatever the information we are conveying from one element to the other element, that information need to be intact and very secure. So there are solutions like encryptions, maybe in the form of SSL or TSL. There may be a solution related to identity management, and you may use some firewall or anti-grabbing critical infrastructure solutions in order to secure those information. Let's take an example problem. So if we have a question like which network technology is best suited for smart parking sensors buried in the smart asphalt. So if some sensor is buried in the asphalt, that means we need to have some technology which can penetrate underground. So as we have already seen, this type of thing is possible with the LoRaWAN only. So here the solution will be LoRaWAN. Now, whatever the solutions we are providing for the smart city based on all this data coming and processing of these data, but directly providing these solutions or directly implementing these solutions to the to any city will be cumbersome, and there is always a risk involved, like whether these solutions will be successful or not. So in order to solve this problem, there is a concept of digital twins. Digital twins, that means we prepare a replica, or you can say virtual replica of a physical city, in which we simulate whatever the changes or whatever the solutions we are providing for a smart city. And based on these simulations, we actually check whether we actually assess the percentage of success or the efficiency of the solution. For an example, we can simulate the effect of new flyover on the traffic congestion before building it. So in this lecture, we have seen that we can see the city in different stacks. These layers in the stack will be sensors, network, process and app. And then we have seen that the right network choice has to be done based on whatever the use cases are there. We have also seen that the use of edge computing reduces the latency and efficiency of the system. And also we have seen that GIS provides the spatial context for a smart city solutions. So this is all about the lecture 2 of second week. Thank you so much.